This is video lecture for week number 14, part 2. Here we continue the method of substitution to find the integration. We now consider an example where we use the method of substitution with a twist. Let's see an example. Integration of x times square root of 2 minus x dx. So here we substitute u is equal to 2 minus x. Then du becomes minus dx. So I multiply minus and this becomes minus dx. Now since u is equal to 2 minus x, then 2 minus x square root becomes root u. Then minus 1 dx becomes du. Now this x we can write, since u is equal to 2 minus x, then x is 2 minus u. So this x is 2 minus u. Now this x dx becomes u du. Here this you cannot multiply, but these two can be multiplied. That means I can open the bracket. When I open the bracket, it becomes 2u half u to the power 1, u to the power half multiplied becomes 1 plus 1 by 2 becomes 3 by 2. These two are integrable. So 1 by 2 plus 1 is 3 by 2. So 3 by 2 by 3 by 2. 3 by 2 plus 1, 5 by 2 by 5 by 2. 3 by 2 becomes 2 by 3. Therefore minus 4 by 3. Then it is 2 by 5 in u plus c, because it is an indefinite integral. So we need to put back u as 2 minus x, and that's the answer. Then we have another example or another what you call method where we are finding the value of definite integral by using the method of substitution. So what we need to do in finding the integration of definite integral by the method of substitution is that you must change the limits of the integration as soon as you change the variable. We know that we are given fx dx, and that variable we are converting into fu du. So this AB, earlier these are the values of x because it is variable is dx here. So this AB are the values of x. The moment you change x dx to u du, you need to change the limit, which this AB are the values of x. Now it becomes, we need to find the values of u. So how to find these values of u from values of a? This, when you whatever the substitution you are using, in that substitution you have to put x is equal to a to find the lower limit, x is equal to b to find the upper limit. So you remember that in finding the value of definite integral using the method of substitution, you must change the limits of the integration as soon as you change the variable. Let's take an example. 1 to 2 x cube square root x4 plus 5 dx. You put u equal to x4 plus 5. Then du becomes 4x cube dx. So we have 4 here extra. There is no 4 here. So I will take 1 by 4. See, I have taken 4 here. So this we can write like this. Now this part is root u and this part is du, that is this. Now the question is here, this 1 and 2 are the values of x. We need to find the values of u. So for that I put x is equal to 1 in this substitution, then you get u equal to 6. Then you put x is equal to 2 in this substitution, you get u equal to 21. So 1 to 2, which are the values of x, now becomes 6 to 21, use which are the values of u. Integrate this, it is this, then you put u equal to 21. and then u equal to 6. This is the answer. So another example, 0 to 15 t e minus t square by 2 dt. So this 0 and 15 is the value of t because it is dt. So I put u equal to minus t square by 2. Then du becomes minus t dt. So you have a minus here. So I will take multiply with minus here. So I can write the given integral in this way. So e to the power this is e raised to u, then minus d dt is du, and this u, this 0 and 15 are the values of t. You put t equal to 0 in this substitution and t equal to 15 in this substitution. You get 0 and minus 225 by 2 is the upper limit. So this 0 minus 225 by 2 is are the values of u. Integration of e raised to u is this, right? There is a minus, don't forget. Then I put u equal to this minus u equal to this. E raised to 0 is 1. The second term is 0 plus, because there is a minus here. So minus this plus 1. So these are the example, exercise 4.6. In example 1 to 4, the substitutions are given and you are finding the integration of this. Already substitutions are given, so there is no need to do any substitution or guess. It is already given. Use this guess or substitution, find the answer of this. In question number 5 to 30, no guess is given, that is no substitution is given. You need to do the substitution and find the integration. And 1 to 30 are the indefinite integral. Don't forget to write plus c at the end of the answer. And in example 31 to 40, these are all definite integral, and the moment you do the substitution, you have to change the what you call the values, which are the values of x, that is 0 to, you have to change as the values of u and find the answer. You cancel this 41 and 42, so means you are going to do example 1 to 40, and these examples we will consider in the live class. These are the answers for exercise, and lastly we come to how to find the values of the natural logarithms using the integral. So for x greater than 0, we define the natural logarithmic function written ln x by ln x is equal to 1 to x 1 by t dt, and this is because this. So this is the definition, and this definition we are going to use to find the value of any natural logarithm. For example, find the approximate value of ln2 and ln3. So applying this definition for ln2, this is the value of x. So 1 to x 1 by t dt. What the integration of 1 by t? Ln t. You put t equal to 2 ln2 minus ln1. ln1 is 0. The answer is ln2. So that ln2, use the calculator and find the answer of that. So 0.693147. Don't forget, find the natural logarithm. ln3, so 3 is the value of x, that is 1 to 3 1 by t dt, using this definition. So it is ln3 minus ln1, so ln3 is this is the answer. What we studied in this week number 14, finding the integration by the method of substitution for indefinite and definite integral, and how to find the value of the natural logarithm using the integral. So that's the end of week number 14 video lecture for week number 14, and with this I completed the syllabus for calculus 1. of this fall semester 2020, and with this I completed the syllabus of Calculus 1, and this is the last video lecture for this semester, that is fall 2020. So examples and all other things we will consider in the live lecture. Thank you one and all. With this I complete the syllabus of Calculus 1 for the fall semester 2020. Thank you one and all.